All right, guys, we're back. We left off last time looking at how to draw a best fit line, and then we also went through finding the equation of the best fit line and then calculating the predicted column and finding the error column. Now this was on the Great Wolf Water Park or something like that. Today I'm going to show you what to do with these errors to try and make a better best fit line. So what we've got here is we've got a table. 10 people went on a diet. This column tells us the number of months, and this column tells us the number of pounds they lost. Now I've already gotten ahead, and I've done the graph, and I've drawn a best fit line. I've calculated the balance point, finding the averages of the x and the y values, or the independent and dependent variables. I've calculated the slope of the line. I used a point out here at 30, 94.4 and 2, 10.4. I've calculated the equation of that line, my first best fit line, is y equals 3x plus 4.4. Now what I want to do is see, can I adjust this line? Can I take this line and tweak it a little bit to try and make it better? Well, better is a relative term, so what do we mean by better? And that's where this concept of something called mean absolute error comes in. Now, to find the mean absolute error, this is all you got to do. You just ignore the signs and you find the average of the errors. So ignore the sign and find the average of the errors. So let's come up here to where I have used the equation right there. And I've done a column of predicted weight loss, and I've found the error. And the error was found by doing the actual minus the predicted. So 18 minus 19.4 is negative 1.4. Now, to find the mean absolute error, what I'm going to do is I'm going to ignore all the signs. So I'm going to ignore those negatives. I'm going to add these numbers up, and I'm going to find out what the average is. So let me take you through that. Again, you know, if at any time you feel like you need to, go ahead and pause the video. All right, so I'll do that calculation right here. I've got mean absolute error equals, and I've got 1.4 plus 8.4 plus, I'm not going to show all the numbers, you can find them, plus 8.6. So this is showing where I'm adding up all those errors, and then divide that by 10 because there are 10 people, and you get a mean absolute error of 4.88. So the mean absolute error of my first predicted line is 4.88. Now what I want to do is tweak this line a little bit, and I'm going to adjust it a little bit, like just go from that to maybe that a little bit. I'm still going to go through the balance point. And let's say I do that. So I'm going to hold that point right there. And let's say I do something like this. You get the idea that I'm eyeballing this, and that's exactly right. So let's say I make that my new best fit line. Well, now you have to go back through all the calculations to find the new equation. So you've got the balance point, you have to pick 2 new points, you got to find the slope, that whole thing. So you come up with the equation of this line. So I'm going to ask that you just trust me that I've done that already. I'm not going to show that bit. And I came up with the equation y equals 3.47 x minus 0.78. Now if that seems oddly specific, so there it is, 3.47x minus 0.78. If that seems oddly specific, it's because I used a regression formula on a calculator to actually figure out what the exact best fit line equation was. And we're going to see what we get with the mean absolute error. So now I'm going to take that new equation, I'm going to plug in these months, and I'm going to get a whole new column of predicted, and that will generate a whole new column of errors. So I've already calculated those. I'm just going to write them down. We've got, for the first one, we've got 16.6. So I got that by putting 5 into that equation, the new best fit line equation. So 16.6, 6.2, 51.3, 33.9, 61.7, 27.0, 16.6, 44.3, 79.0, and 37.4. Now I have to get a whole new error column, so I'm going to go back, take the actual weight, subtract the new predicted to get a new error column, and I've got 1.4, negative 4.2, 2.7, 5.1, 3.3, negative 2.0, negative 4.6, negative 3.3, negative 7.0, sorry, negative 7.0, and 8.6. Now, if I calculate the mean absolute error of those, this is what I get. A new MAE, mean absolute error, equals, you add up those numbers ignoring the negatives, plus 4.2, plus dot, 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 plus 8.6, divide by 10, and you get a new mean absolute error of 4.2. So notice that is actually a better number than that. So this second line I've drawn, the light green, neon green, is a better best fit line. Now I skipped a lot of stuff, I know, because I already had it calculated, but I didn't want to take up a lot of time on the video. But that's how you take a best fit line, make adjustments, and then actually measure, is your new best fit line better than the old one? Now, let's be honest, you're never going to do this by hand. You're probably going to, if you have to do this in a career, what you will do is you'll use computer software to generate all this. But it's important that you understand what you're asking the software to do. Okay? So I've got a couple problems for you to practice this by hand. If you know how to use a graphing calculator, you can use it to check your work.